gonna go ahead and open this up. CD into vendor. Actually, I don't even think I have it added, do I? Got that. Emulator. No. Okay, so let's go ahead. We're gonna say vendor. And then I'm gonna go get sub module add. So all this just for memory tracking support. But good news is now that that's done, I will never have to do that again. Slash that. Okay, so we got that. Yeah, cool. Gonna add this. We're gonna add this. No, it didn't copy it for some reason. What the heck? Copy. Paste. No, okay, whatever. HTTPS / that, and we're gonna add it to emulator / vendor / CPP utils. Okay, we've got that there. Cool. Go back into here. That's fine. Let's go include directories. Where is that at? Okay, yeah, we want to do that. And then emulator / include / CPP utils. And we should be good. What's that? There. Single. Oh, I need to do. Wait a second. Single include. Okay, let's try that again. CMD build. Okay, going back into here. That should regenerate the project. And it's not. Oh, because I was building the wrong thing. Okay. Let's go into here. Okay, build that, which is the correct project. There we go. Hash include. No, it still doesn't want to do that. That's interesting. Double check this and make sure that I have that added as an include directory. Yeah, it's in there. Emulator / include. Oh. Cancel. There we go. We do that. And now, I promise we should be good. Include that. Okay, there we go. So now, we do this. I will also have to go into here and do this. And if we run this, we get hello world. Okay, cool. And then I could initialize it with a file and everything too if I wanted to. All that stuff. Sweet. Okay, so project is set up for C now. Finally. Let's go memory, or I guess G true, and we're gonna give it 32 bytes of padding. Okay, we do that. And do I have to do anything else? Free. Okay, I guess I do. No, I don't. Okay, cool. Oh, and I guess one more thing. Oof. I'll do that after stream. I'm gonna have to do one more thing, which is like add a free so that we free our allocator for our memory tracking at the end of this. So when we dump the leaks, I should also free all those so that we don't leak any memory. Or at least just add a free system or something. Okay. Anyways, though, that's good. That's good. So if I were to do that, we should see a memory leak detection. We do. Okay, cool. So we've got that done. Let's just go ahead. New item. Actually, I'm going to put this in source. We're going to call this vendor impulse. Okay, we're going to go ahead and put this in here. This way we have one implementation, which is defined in here. I guess technically, okay, let's move this into include just to get that right. Zachary Hutton, thank you for following. Good to see you here. I promise we're finally going to start working on an actual emulator now that this is all set up. After all that pain and suffering, we should be good now. Let's go include vendor impulse. Yes. One more thing I'm going to do too is I kind of like to do this now is include. We should also do that because I hate it when things aren't namespaced properly, so that when we do this, it's that, because it gets really annoying if you have multiple libraries and they don't do that. So I always try to do this now. Okay, let's do that. We should be good. Discard. So we include that. That should actually provide our implementation, and then we can go ahead and say that, and we should get our not implementation, but this should give us just like the access to it. So then if we were to do we should get a memory leak detection and everything should work out. Yeah, so it just compiles it into the project, kind of like a STB library. And it all just works out. Okay, so now let's at least add some code. Let's go ahead. We're going to have our, I guess, VM. We're going to have a virtual machine that runs our emulator bytecode, all that stuff. We'll add some very basic stuff real quickly just to get that up and running. So we're going to have a virtual machine. We are going to have a interpreter. I'm not sure how I want to do all this. We'll figure it out. And as we go on, I will probably change stuff around. Okay, so let's do emu for emulator, I guess. Okay, emu, VM, init. Okay, so we got our init, we got our free. And now that I've got this here, how exactly do we want to run this? Do we want to be able to just hand it some like bytes and be like, interpret this or process this or whatever, right? Or do we want to just give it a whole program and be like, interpret this, process this? I mean, I guess it's technically the same thing. Like it really doesn't make that much of a difference. Yeah, let's just do that. We'll say void, which if we do this, I guess there's not really much reason for initializing or freeing it or anything, but maybe there is. Yeah, okay, there is. Okay, so we're gonna have to have a struct emu VM. We'll call it virtual machine. We'll actually give it that. The reason we need this is because we will need like program counters and stuff. So that is kind of important. Program counter. We're going to make this 32 bits, even though that's not technically up to specs. Like I think actual 6502, the program counter can only go up to a certain range. Let's just check this real quickly. We'll make it as close as we can. So NES program counter max count. Wait, no, I don't want programming the NES. Let's go into here. Let's see if they tell us in here what the program counter's max count is. So we have addressing modes, instructions, memory map, power up state, registers, interrupts, unofficial opcodes. This is for the CPU. Okay. Mad Flash 19, register, stacks, etc. No stack. Looks to be 16-bit. Type def struct. Wait, okay. Oh, thank you for the type def struct too. I'll have to add that. Okay, so register, stacks, etc. I guess we'll go into here, see? And Voxers, how'd you find out 16-bit? I'm interested. Can you post a link or does it not allow you to? Oh yeah, program counter. Thank you. Okay, yeah, Mad Flash 19 and Voxers. Thank you. So the 2-byte program counter supports 65,000. Yep, so 2 bytes, 16 bits, which means we just do a uint 16. And now we're at the same level as they are. Okay. And then I guess what we can do is we can add some error handling and stuff, etc. at some point. So the other thing we need is uint 8. I believe registers are only 8 bytes. So accumulator. Right? So we have all of our registers too. Yeah. So we have accumulator. So A is byte wide, which is 8 bits. Along with the ALU, supports using the status register for carrying overflow detection and so on. X and Y are byte wide and used for several addressing modes. They can be used as loop counters. Yep. They have limited addressing modes when loading and saving. Okay. I guess we'll call them... yeah, we're going to call it accumulator and then X register and Y register. I'll append reg, just so that it's clear it's a register. Mad Flash, have you written an assembler before? Just curious. No, I have not. So this is my first time doing any of this stuff. I am just kind of going based off of what I think makes sense. And I may have to change stuff up eventually, yeah. And Voxros, the stack overflow question, you just said if it acts as an 8-bit increment, but on the lower byte of a 16-bit counter. Oh, okay, I see. So anyways, we've got our program counter, accumulator register, X register, Y register. What else do we have? Stack pointer. Okay, that's true too. It's 1 byte, can be used accessing interrupts, pulls, pushes, transfers, and then a status register. So we'll add support for those two. Okay, and then a status register. 6 bits, it's used by ALU, but is byte wide. PHP, which I can't remember what that stands for. I think that's push something, pull something. Okay, so we're gonna have a status register. I'm not quite sure what that contains yet, but we'll figure that out eventually. Okay, so this is actually going to... And to do that, like Vakra said, we need to type def this. Okay. So we've got that. We want to initialize it, and we also want to free it. So that's your VM. And then if we ever want to do something, emu VM execute. Or I guess we should have like a tick, right? So this would be a clock cycle. So we tick 1 clock cycle or whatever, and then we'll call this at a fixed increment or whatever. And this will take in our VM and I guess our bytecode, which is our program, I guess. So we'll do that. And then we also need a size T program size, right? So we give it our virtual machine, which contains the state of the program. We give it a program, we give it the program size, and we call tick. I'm trying to be as forward thinking as I can, right? Because I want to build a debugger for this and everything eventually too. And so if we encapsulate all of this kind of like this, we have access now to our virtual machine state. So we can go in a debugger and we can pause execution at any time while we're inspecting different parts of the memory, whatever. Oh, and that's another good thing too. So a virtual machine contains a fixed amount of memory. How much memory do you get in a 6502? I guess it really doesn't matter. We could give it as much as we want, but I'd want to see how much the default memory limits are. So memory map. Okay. So 0 through 07FF is 2 kilobytes of RAM. This is just crazy, right? This is why I want to do this, because I really want to program games with these limitations just to get an idea. 64 kilobytes. Yeah, we'll bump it up. I'll add an extension, right? So we'll have like a RAM. Let's do that. So when we initialize it, we'll say uint. Wait, doesn't make sense though. Can we do 64 kilobytes? Yeah, we should be able to, because you can always address more memory if you want, if you program your program appropriately. So we should be able to. Since PC is 16-bit, yeah, okay. I think that works. Well, that's for ROM. So the program counter is for ROM. But let's just do, we'll do a 32 ROM size. Right. This way you can alter it if you want. I don't know, is NES, is the program, and so is ROM and RAM in the same memory unit, or do they have separate memory architecture is also something I'm kind of interested in. Let's just see. So it has 2 kilobytes of internal RAM, I guess default. These are mirrors of this. I wonder why they have mirrors from 800 to FFF. Just check this real quick. Memory mirroring is when the same memory may be accessed at multiple addresses, causing an apparent duplication. Ah, okay. So I'm guessing they mirror the memory so that they can easily do like double buffering or triple buffering or whatever. That's what I'm assuming. I could be completely wrong on that though. This is all just, we're going to figure stuff out as we go. 2000, 2007 is the NES PPU registers. What are the PPU registers? So 8 memory mapped registers to the CPU. These nominally sit at 2000 through 2007. Okay, so they're mirrored. The PPU isn't necessarily in a usable state. The program needs to do a few things to get it going. Yeah, so there's a lot of stuff. We're just going to kind of slowly go through this and add more functionality as I go along. Because, yeah, there's a lot of stuff here. And I'm not going to exactly implement this correctly the first try for sure. Okay, let's go back here. And then what do we get? We get from 2008 to 3FFF. Oh, I see. This is internal RAM. Okay, yeah. So that makes sense. So internal RAM, I'm guessing, is reserved for like blitting the screen and stuff. Yeah. And then we have 4000 to 4017 NES APU and IO registers. Okay, so I'm guessing these are like for getting inputs. And what's an APU? Arithmetic something? Audio processing unit. Okay. Okay, that makes sense. So basically what we're going to do is we're going to use these memory regions. Yeah, and then IO, just double check that. Ah, okay. Joystick 1, joystick 2, sound. Interesting, okay. Cool. So yeah, this is basically like for inputs and audio, I guess, is what those ranges are for. And we can eventually like hook all that stuff up so it works properly. I'm probably going to try and get a window up and running too after we get kind of like a basic thing going. 4018 to 4001F. CPU test mode. Cartridge space. Okay, so then the ROM. Yeah, so they are separate. PRG ROM, PRG RAM, and mapper registers, which is 4020 to FFF. Okay, so we got that. I'm just going to let you pass it in, and then I'll do like a... this, which that's going to set that to, what is... We're just going to set it to whatever this is. FFF minus 4D20. I'm not going to try and do this in my head. Okay, calculate. 81,951 bytes. Is that right? Oh, it gives you the size right there. Oh, that's helpful. Oh, I have the $sign in there. That probably is messing with things. Okay, BFE0. This, I don't like this website. Okay, let's go back here. Convert. Okay, yeah, 49,120. So we'll have ROM size be that, which is that. Let's not use that guy. We're going to use that guy. Okay, so 49,120 bytes is going to be our default. I'm getting all confused here. So default ROM is that, and then default RAM is 800 hex. Okay. Well, 800 hex times 1, 2, 3, 4. Let's just double check that. Yeah, 2048. Okay. RAM size is going to be times 4. Right? Plus 3 mirrors for a total of, what is that? Well, actually, yeah, we'll just have the mirrors. Okay, so we've got, that's not what I meant to do. Okay, we've got, I keep pressing the wrong keys here because I'm still getting used to this new keyboard. Okay, so we've got that, that's 2 kilobytes. And I guess that's like what, around 49 kilobytes, kind of? Yeah. So we've got that, and then we're gonna have a UN 8-star RAM, ROM, and we want our mirrors too. So I guess UN 8-star mirror 1. I guess we could just call this mirrors, and then this will be 3 mirrors. Incomplete type not allowed. That's not incomplete. Okay. So yeah, we've got 3 mirrors, we've got our RAM, and then we've got our ROM. Okay. 3 mirrors, same size as RAM. Cool. Let me just check chat real quick. So, no overloads in C. Oh yeah, no, I totally get it. But we're overloading by doing that, you know, Java overload style here. And Tinspin, here I was hoping for a C64 emulator, but I guess NES is okay too. Well, what I want to do too is I want to have like, you know, something like that, right? And then VM type. And that'll initialize it with the defaults of different things, because I think and then we can have it like interpret different styles of whatever. So let's actually do that. Good idea, Tinspin. Thank you. So we're going to do typedef enum, emu VM type, right? And then we're going to have a emu VM type. And then inside of here, this will be, I think this is 32 bits. So VM type. 32, 16, 1, 2, 3, 4. It's another 32. It shouldn't matter too much. I'm thinking about this too much. Okay, so then we're gonna have a NES. And then we're gonna have a C64. I guess we'll call it Commodore. Right? And so this way we can create different VMs and stuff, and then hopefully import all that and everything too. Morphcat is streaming in Twitch too. They made a 4-player NES cart recently. Be aware, C64 is another beast altogether. SID and VIC2 64K RAM. What's SID and VIC2? You're gonna have to explain. But thank you for the admonition there too. I will have to beware. And what I plan on doing is like we'll have this, and then afterwards what I can do is I can, since this will contain the type, we can go ahead and like add different interpretations and all that stuff too. But this at least gives us sound and graphics. Okay, thank you. And that's probably a good idea too. I should probably have like sound, RAM, and whatever too. We'll add those stuff as things go on. But yeah, I appreciate that. Because just having this here just at least makes it a little bit more extendable, so that we can at least go ahead and think about that as we're coding this stuff and everything too. Prefix with name. Thank you. That is true. EMU VM type. That's better. Okay, so we've got our type, and then that will just automatically be embedded in our virtual machine so that when we're going and interpreting and all this stuff, we can hopefully go ahead and do all that stuff. So let's go ahead. We're going to have a virtual machine.c. Something about coding in pure C, it just makes me so happy too. I don't even know what it is, but you know, it's just nice. Okay, so emulator virtual machine. Let's go ahead. So this we'll just call which are 49. Can I do this in C? Does it allow me? It does. Cool. I don't know if that's technically appropriate, but it lets me do it. So yeah, 2048 times, oh no, just 2048. Okay, so what we can do too is we can just say if emu VM type NES, right? Okay, and I should probably change this to just update the docs here. NES type, and then, yeah. Okay, we'll do that, right? I don't know, like at. Hopefully just make those a little bit more visible. Okay, so that's what it's initializing stuff to. We're gonna leave that unsupported for now. Else, no support for, let's actually just, okay, we'll do that. And then else, okay, we'll do that. And so if that happens, and also we want to return this, we'll have our EMU. Ooh, and now I can do this because we have C style declarations, right? Is this going to be, I have to do equals. Dot, there we go, accumulator register equals 0. Null pointer, I guess we should do a null. Dot program counter. Dot, man, see, this is just so much nicer. I wish C++ allowed this. RAM size is 0. We'll do that. Dot ROM size is 0. Dot, what are we missing? Stack pointer, stack register. Okay, move that up there. Stack pointer. Get rid of that comma. Stack. Oh, status register. Dot, so we got accumulator, program counter. We need our X register and Y register. I think that's it. And then type. Yeah, okay. Cool, and that should be it. And then we will just return our dummy. No offense to him, he just doesn't work right. Okay. Oh, if everything is 0, just do 0. Yeah, I guess this that makes much more sense. Yeah, I didn't even think about that, but thank you, Vox Riffs. Once again, coming in clutch there. Okay, once the stream is done, are we turning off the computer for the rest of the weekend? Probably not. Maybe, I don't know. I'll probably be doing stuff. Sorry, my microphone keeps like dipping down slightly. I'll probably be programming slightly on Saturday and possibly Sunday. Usually Sundays I don't program. I'll usually just like relax then. So it all just depends. But yeah. Okay, so that was a big waste of time typing all that stuff out, since I'm just gonna have to type it out again. I should have saved it. So if we go into here, let's just do that so that I actually have it all there for my reference. So if we do this, VM equals, so type, we need to add our type there too. Should I allow you to pass your own RAM and ROM size too? Because if you pass it, that could change stuff quite significantly. So I'm wondering, should I allow you to pass it, or should this be an internal function only? Curious if you guys think that should be one way or the other. Do I have a laptop that I sometimes use for programming? I do have a laptop, but it's from college. It's like 7 years old at this point, 6 or 7 years old, and I don't use it that much anymore. It has Linux on it because Windows, there's no way that's running on there. But yeah, I haven't used it in years, so I usually just stay on here, which is fine with me. Like, that keeps it constrained too. That way I only program when I'm in here. So that's probably the best thing to have. Let's do all this. .yreg .status. .mirrors. Oh, I guess we should do RAM. Okay, and so this is where I should actually do a little bit extra. Well, I guess it really... Can I just do all this inline? I mean, I don't like doing this inline. Yeah. Let's do that. .mirrors equals... mirror pointer 0, 1, and 2. Okay, we'll do that. And I'll implement those in a second. So we got mirrors. Okay, so we got all that. Oh, and is the ROM really important too? That is kind of important. Okay, so that kind of brings into, I was gonna do it this way, but if we are loading, okay, so I guess we're gonna have to change our API just a little bit. So we're gonna have to say load program, right? And I think I should do this. So underscores are for namespacing, and then functions are camel case. So we'll have virtual machine. Oh, and if that's the case, then this is typed wrong. So let's fix this real quick. So virtual machine. No, okay. Trying to think. Yeah, I would rather do this. Okay, we're gonna do this. Fix this. Type. Type. Okay, virtual machine. Let's fix this first. Type. Let's fix that. We'll fix that in a minute. And then this will take in a VM. All that stuff. We'll load the program and then we can tick through the program and stuff. Just a slight change. Okay, let's go fix this. We just need to do that. Virtual machine, copy that. Copy, paste. There. And there. Okay, so we're gonna do that, and then this way when we load it into ROM, we'll just copy and all that stuff. So EMU, oh, and if that's the case too, well, I guess, so we have VM for namespacing for virtual machine, so this is fine, yeah. Okay, I am okay with this. So let's just keep it this way now. Hopefully I'll keep my naming consistent. We'll see if that actually happens. Okay, we'll do that. And that. Let's go ahead. We need to This is now initialized. UN8 star RAM pointer equals. Okay, let's go ahead and do that. Which this is just 1, but it's always good. I don't know, it's probably not good. I don't care. Okay, UN8 star. I was gonna say it's always good to type safety, but I guess since we're in C, type safety really doesn't matter anymore at this point, but whatever. Okay. Our mirror pointers. Okay, mirror pointers 0. Right, we got that. Got that. Okay, and then we want our ROM. Size of that times, I almost did what voxel riffs did the other day and did size of pointer. Those are subtle bugs, and I don't want to be doing that because I know how painful that is to debug. Okay, we'll return VM. Cool, so we've got all this. That is all set up correctly, hopefully. Let me just check chat. Maybe IC required added a VM type custom, which uses property set before. That might be a good idea too. Like having a VM custom where you basically set that and then you can set up a custom RAM size and stuff. The reason I kind of I'm wondering if we might want to provide an API like this is because with an NES, you could get like a RAM cartridge, right? NES RAM extension cartridge. Right? You could do stuff like this. Yeah, so you could upgrade to 16 kilobytes of RAM. And a few things actually did. VR Tech. Yeah, so that's why I kind of want to do that, because like similar to how you might upgrade your RAM cartridge or whatever, I kind of want to leave that in there just in case you want to upgrade your VM types RAM. So, yeah, just kind of curious. There's different ways you could do that, and I didn't know if this should be like extension or whatever. I don't know. SE Woods, I was just imagining you bringing the laptop when you're hiking in the mountains. Yeah. Nah, when you're in the mountains, you're in the mountains. You don't bring laptops and technology there. You just live in the mountains. At least that's the way I like to do it. Okay, so if we're loading a program, how do we load a program into our VM? Well, first of all, we just make sure, oh, and that should be VM star because we want to pass that by reference. Okay. So first of all, we want to assert our VM is not null. You know, make sure that our assertions are correct. Null VM. So, oh, and that should be, yeah, I'll fix that in a second. Program does not equal null. Okay. There we go. So we just want to make sure that, I guess technically you could load a null program. Do we want to support that though? I'm going to say no. So then our last assertion will just be cannot load empty program, right? Maybe to do, should I allow null programs to reset ROM, or should I just add a function for like reset ROM? I guess is kind of the way you could go about that two ways. I think I like this better. So we assert everything's correct. Then how do we actually load that program into our ROM? One more assertion. We want to assert that our VM's ROM size is less than or equal to the program size. And actually, do we want to assert that? Maybe we want to return errors here. Yeah. Let's return an error. So we will also have type def enum emu VM error. Okay. emu VM error. So we will have this, and we'll grab that. None, which equals 0. I think that's how we want to do that. We might have to change this. Error, invalid program. Or I guess we want to do like not enough ROM. Yeah, that works for me. So we'll do that. This will return an error. And we can just kind of grow that as needed. So if we're loading a program, it has the chance that it can return an error. If the VM's ROM size is less than the program size, we want to return emu VM error, not enough ROM. Okay. And otherwise, we're just going to return none. I don't want to do error success. We're not doing that like Windows. But yeah, as you would, just imagine that. Truer words have never been spoken. And what problem did I run into when setting up Odin? I mean, honestly, it just didn't compile. So it's got warnings, first of all, and he had the warnings set to on. Yeah, so I was in here. I was going to do this all in here, but guess not today. But yeah, let's see. Where did I put it? I put it in here. Odin Lang. Yes, right there. So, actually, we can't do this. VS developer command prompt, cd to that. Okay. So inside of here, if I say build.batch, I turned the force warnings off. Did I? Yeah, I did. So I think, yeah, the linker errors are all because of LLVM. Even though LLVM is defined here, but I have a feeling it's because this is like AMD, because that's all his other default binaries. Yeah, it has pre-built. Well, no, the pre-built binaries were all AMD 64. I have Intel, so I don't think that's going to work out on my machine. And I think this is the same problem. I think I have to build LLVM myself and then add the binaries here if I want this to work right, which is annoying. And I just didn't feel like I didn't have time to set that up, first of all, and I didn't feel like setting that up, second of all. So yeah, we're just doing it in C, but I'm fine with C for now too. This is a good exercise, I think. I have Intel and they worked fine. Okay, so it said AMD 64. I didn't know if that was going to affect anything. I probably should have tried it. So we will eventually, I'll eventually learn Odin, and then I'll try it again and stuff, and I'll have a stream where I do Odin stuff, which could be cool. Okay. Otherwise, if we have enough ROM, then we can easily copy our memory to our ROM. So a copy to our ROM. I really should have this be safer, but whatever. We'll fix that eventually. So I guess I did just check up there. So we have enough room here. So a source is going to be our program. Number of bytes is size. Guess technically, no, yeah, that's fine. Cool. So now we have load the program into ROM, right? We have now loaded our program into ROM. We're good. Yeah, and I think that's it. Like, that's all you need to do to load a program. I mean, okay, so technically you also need to reset some things. Well, I guess what we could do is we'll do this. So void emu VM init program. Right, and so, yes, I just need to change that. This will be used for reinitializing a program, or I guess the state. So you call this every time you want to just basically reset program state and everything, or I guess the whole VM state. And then you can start calling tick and free. Yeah, I think this is probably gonna be the best way. That way, if you want to rerun the program, you don't have to reload it and everything, because that just seems like a waste. So if we do this, then basically what we want to do is we want to set our program counter to 0. We want to set our accumulator register to 0. I guess basically just most things. to 0. We don't want to reset the RAM or RAM size. Well, actually, maybe we should 0 out RAM. So we'll 0 out our RAM and our mirrors. So RAM, and then VM RAM size. Mirrors 0. Oh, RAM size. Right, so we'll do that. Do that. VM, we want to set our X register to 0. Our Y register to 0. Okay. And then VM, what else do we have? We have mirrors program. We want to leave the ROM alone. Stack pointer to 0. And let's see, status register to 0. Type is fine, registers. Okay, cool. So we set all of our registers to 0, and then we 0 out all of our RAM, which should be good with me. Yeah. And I guess our mirrors probably shouldn't be the same size as the RAM, because technically that's all embedded within the RAM itself. Wait, let's go back here. Okay, yeah, so I think this 2 kilobytes of RAM. Oh, wait, no, yeah, it says size. Oh, no, okay, yeah, so 07FF. Okay, so this is all embedded within the RAM itself. Okay, so I guess technically we shouldn't have any mirrors, but let that kind of be dictated by the way the memory map works. Is it? Wait a second. No, yeah, this is fine. Okay, never mind, this is fine. This is just for mapping our stuff to internal memory. Okay, so this is fine. Okay, let's keep going. I want to get some very basic interpretation going, and we're pretty close there, so we should be able to do that. Oh, and we should also... We'll go ahead and do that. So that... Okay. And biology as well. Thank you for following. Good to see you. This is the stuff I can get excited about. I hope you guys get excited about this too. So, yeah. Essie, did I feel up with breakfast or did I start the morning with coding? I guess I had a muffin. So, yeah, I do eat a muffin for breakfast, which is nice. Okay, one other thing I'm thinking of too. Do we crash if we have things like this, or should I just say... and return our error code? Why not? I agree, yes, with the breakfast. And I have a nice chocolate muffin, because that's awesome. So I think what we should probably do is we should just return errors here. Yeah, I think that's probably the best way to go. So emu VM error null VM. And then let the user handle it. Because there's, I don't know, because there's certain errors that you want to crash on. And then there are certain errors that you want to handle. I guess we'll just, yeah, we'll leave the option for handling up to the user. Okay, so we'll do that. Oh, and we can't do that here, can we? Oh, well, that's fine. Okay, because that's just initializing anyways. Okay, cool. Should that be called init or should that be called create? I don't know. Doesn't matter. So for here, what we'll do is we'll just say if that's null, yeah, we'll just do that. Okay, and then should this return an error too? I think this probably should. Yeah, so we'll go ahead and we'll add a null program. And we really don't need to do that anymore. So we'll just let that automatically count up. Okay, so null program. and empty program. Change this. Return and we'll do the same thing here. Okay, cool. So that's where we check our assertions, and then I'll return an error if any of that's wrong, and then you just do that stuff. Same thing here. Okay, we'll just return a null VM. Otherwise, we can continue. This should all be fine. I'm just going to assume that if the VM's not null, then its stuff is correct. I should probably have assertions in here just in case. And these will be actual assertions, because at this point, if it's bad, then that's not good, and that's an actual program error, and it should crash here. Null. Right, so if we do that. Same thing here. Same thing here, and then we'll do the same thing. Okay, do that. 1 and 2. 1 and 2. Okay. I'd rather have all these assertions than have it break, right? So better to add it than not to have it and need it. So if we do that, our assertions are correct. This should all be fine. I guess I could add one more for the RAM size, but that doesn't matter. If we zero memory with a 0 size, that shouldn't do anything. Okay, so when we free stuff too, what we can do is we can just say that we'll free the RAM, set it to null. We'll free the mirror and set it to null. Same thing with mirrors 1 and 2. Okay. Based on that keyboard sound, that must be one expensive piece of hardware. Hopefully it's not too loud coming through there. It's really not that loud. Like, I know I've seen some with like the super thick keys like that you really press, and I hate that. So this is kind of in between, which is nice. If VM ROM equals null, and this is something I forgot to do too. Let's just set that and set that. Okay, so that should be fine. We free it. Yep, and that's basically it. I guess we should set the type to none. Yeah, and I won't worry about memory or zeroing out the other stuff. Well, actually, I guess after that we can just say g memory VM and size of EMU virtual machine. Okay, so we just zeroed out. That should set everything back to normal. Cool. Some speed coding going on. I guess so. That's true. Okay, so now we've got all this stuff. Now we need like an app in it and stuff. So let's go into here. Okay, and this is another thing too. We probably want like a runtime, and we want debugger. So I'm gonna start coding our debugger first, and then we'll add a runtime once we're ready to build distributions and stuff. So if not defined, emulator that. Okay. And then we want to basically have like a void emu debugger init, right? And then void emu debugger free. And we probably want like a void emu debugger update. So we'll have a window. Do we want a window? We do want a window. But I'm not going to worry about that in this stream. We'll probably worry about that next time. So we'll have a window that calls like init update free. Yes, and then the debugger will hold debugger state so that it can actually do things like set different things. So like if it's in a breakpoint, it'll update all that stuff. So yeah, we'll have that. Type def emu debugger. I guess emu, yeah, debugger. And then that's a emu debugger. I like that the prefix also conveniently spells emu. Do I have to do that? No, I have to do struct. That's what I'm missing. Okay, so we've got emu debugger. For now, it's just gonna be empty. Right, and then this will take in that, and we'll just give it that. Cool. And for this, we need a C++ file or a C file. So go into here, copy that, emulator debugger. Okay. So this will just return empty for now. Since this is just an empty struct, it really doesn't matter. It doesn't like that. Too many initializer values. Okay, since it has nothing in there, we can't even do that, which is fine by me. So we'll do that, and then for free, we just, yeah, do nothing for now. Okay, these are just stubs. We will fill these out later. Do I have software app ideas that I write down for potential future projects? If yes, you don't need to reveal what they are. Actually, I don't. I just kind of do whatever I am feeling at the time. This one has been like, usually whenever I have an idea, it's like, it'll be something that's I'm thinking of. I'll think on it for a week to a month, you know, to 2 months. And then eventually it just like culminates and I'm like, yeah, I think I can do that. And then I'll eventually just be like, okay, now I'm going to program it. So, yeah, I kind of let it sit there and fester, and then it grows. And then eventually I want to actually code it, and I end up coding it, which is good, I guess. Right. So, that's kind of how it goes. Let's go ahead. We're going to add an app.h file too. This will kind of like figure out if it's the runtime, all that stuff, or if it's the debugger or whatever, and do stuff based on that. Is the animator you made something that you'll release? Yes. Once I start using it to actually build videos and stuff, I will definitely be releasing that so that other people can use it too. Still debating whether I'm going to release it as a paid thing or if it's free. It'll probably, I think I'll probably like sell it for $15 on itch.io, but it's open source. So if you want to compile it yourself, you can also do that. So yeah. Just like if you want to just buy the binaries, then you can, and possibly support or whatever, you know. But yeah, let's go app H. Thank you, Epic Games. Store event. Great. Cool. You could definitely do that. Yes, and that's kind of what I want to do. I don't know what demand for that type of thing is. I'm guessing it's probably not that great, but still be cool nonetheless. Okay, so compiling is kind of painful though. Oh yeah, compiling. Well, that's why I want to sell the the binaries, because I figure most people probably won't want to compile FFmpeg and go through all that pain. So yeah, that's why I have the option, you know. Kind of, it prevents people from wanting to compile. They're like, oh, I'll just cough up the $15 to do whatever, just so I don't have to worry about that stuff. Yeah. Okay. So our emulator app, we're going to have a type def, or at the very least add a buy me a coffee type of thing. Yeah. The thing is, like, when you give people the option to not pay, usually they just don't pay. And I don't know, maybe I'll change that in the future. It all depends. First of all, I have to have a working product, so I have to actually finish it and make sure that I'm using it and it's working. So I can't exactly start making big plans quite yet. But eventually. Let's also go ahead. We're going to forward declare a emu debugger. Right? So we forward declare that guy. What else? We have our virtual machine. We probably want to forward declare that guy too. Can we forward declare like this? Or can I not forward declare like that? I might just have to do this. Okay. And then I'll just like say struct emu debugger star VM. Okay. Can I not forward declare like that? I guess I can't. I don't know. We'll try it out. If it complains, then I'll change it. That way I don't have to do that. Okay. So yeah, we've got that, and then we'll have a emu app in it. I guess emu app in it. And then we'll have a void emu app free, which takes in the app. Okay. Where's my syntax highlighting? Come on, catch up, Visual Studio. Doesn't like this for some reason. Yeah, that's fine. Weird. I don't get why I'm not getting syntax highlighting here. Let's also just do that. Okay, now it is. So clearly I was missing some sort of declaration. I wonder what that was. Why is it? Was I? Nah, Visual Studio is just being slow, man. Okay, that should be fine. Voxer, so you have to do typedef that. Okay, that'll work. Cool. Just fill the free version with ads. No, I definitely don't want to do that. That's disgusting. And Voxros, what's for coder for the win? Is that for, oh, because Visual Studio is being slow? Yeah. It's because they're not used to C. They're confused, you know? It's okay. They'll catch up. He's confused, but he's got the right idea, right? Oh, and I named that CPP. That should be not CPP. App.c. Let's rename this to C. I think this is the first C project that I've actually done like full C going, you know, all the way. I've never done this before, so it's definitely interesting. Emulator / app. We'll also include that, not that. Okay, so do this. We will give it a debugger and a VM. I guess we could do that, and return app. Debugger equals, oh, and this is where we actually have to start including some other stuff. Debugger, include emulator / virtual machine. Okay, so we'll do that. Nope, emu debugger star equals that G memory allocate size of emu debugger. Emu virtual machine. And it's weird, but there's something kind of cathartic about coding in straight up C. I don't know what it is. It's like just the fact that exactly what you see is exactly what you're getting. C is good. Yeah, this isn't creepy at all. Yeah. I think Voxel's lost it again. No, I agree. There's like something, it's weird. Just having all this like no C++ garbage infiltrating, there's something kind of satisfying about that for whatever reason. If app debugger emu debugger free, right? And then we'll do that, and then we'll say app. And you see this, how simple it is. no memory leaks. This is all you got to do, just an init and a free. And then all of a sudden, no memory leaks in here at all. Memory management is not as hard as they made it seem. I don't know who they is, but yeah, that's for sure. Natsu 130, is it works? It definitely does not work yet. But we're getting to a point where I can almost initialize our app. And then I'm going to just run through some bytecode and see if we can do some simple stuff. We'll slowly add functionality as we go through. But I'm probably going to start focusing next time on like the window and getting a debug window and all that stuff up so we can kind of get comfortable and have like some visualization tools and stuff too. Foxhurst, I know, right? The Joya program, almost the same thing I feel with Odin. Yeah, it is weird too, because you wouldn't expect that with C, and that's why I want to go into assembly, because I feel like assembly will be nice too. So we'll see how that goes. Okay, so we do that, and then we'll say if app VM virtual machine free. Is that not what I have? Oh, I think I called it VM free. Yeah. VM. I should probably change that to keep consistent naming, but it is what it is. Okay, free app VM. Okay, we got all that. That's good. And we're good there. That's all we got to do. So we got that. And then I guess we'll have a void emu app run. And we will run that bad boy. And inside of here is where everything happens. So we'll see how that goes. CL Cloudry. I have no idea if I'm saying that right, but thank you for following. Good to see you. And Gabe's going down the rabbit hole. Will he ever come back? I have no idea. Yeah, we're going from high level Odin to assembly. Because, yeah. Have I become the Odin shill like Amogi is the JetBrains shill? Nah, you're not bad. I got a coworker who's a JetBrains shill too, but there's nothing wrong with that. Great Duster. Is there likely to be a part 5 of the Minecraft series, or are you deep down the emulator rabbit hole? I am. So with the Minecraft series, I have been working on the side. I don't know if you were here for the beginning of the stream, but I am still working on this thing, which it's almost at the point where I can finally start using it. I used to use 3 Blue 1 Browns Manum to do my animations, but it had some limitations that were very annoying. And so I've been working on this, which is my own replacement. And it's basically at the point where I can start. Oh yeah, you're fine if you weren't here at the beginning of the stream. But this is basically at the point now where I can finally use this to actually like create stuff. I can go ahead and like, if I say test.mp4, I can go ahead and start exporting videos and stuff. So it's going through, you can kind of see live preview of the export. I've got to speed it up and like do GPU acceleration and everything. But yeah, this is what I'm working on. So streams are for fun stuff, in my opinion. And then in my off time, what I'm doing is I'm working on this so that I can finally get the next video done. And if I hit stop exporting here, if you look, there's a test MP4. And if we play it, it's just the MP4 that was just exporting there. So this is what I've been working on. I am still working on it. I want to get it to the point where it is at the point where I can use it to create my animations and everything. It's got a lot of stuff built in. I just have to actually start using it now and add a few more different animation types so that I can start doing that. But yeah. Always wondered what made 3 Blue 1 Browns animation. That's cool. This is not using 3 Blue 1 Browns animation tool anymore at all too. I coded this all. This is custom. So I used to use this tool and his is all in code. I wanted a visual editor, so I coded this and I've been working on that. And it's finally almost there. But yeah. And that's a cool piece of software. Thank you, SE Woods. Yeah. It's when you're staring at the same piece of code and you're working on the same thing for so long, this is all fine too. Ignore the errors. And you're working on the same thing for such a long time, you can start to like just get stuck in a rut where it's like, I've been working on this for so long, and you're just like, yeah. Yeah. Now I have 2 or 3 rabbit holes. Exactly. So this way I don't get bored of coding. Like this keeps my motivation up, which is nice. Okay, let's go in here. Include emulator / we want to do our app. Okay. So we will say our emu app. And actually we want to say is equal to app init. We do that. And then we say emu app run. We got to give it that app. And we got to give it that app. Okay. let's go ahead. We're gonna do that. And that. Cool. So now we should create an app, run it, free it. We dump our memory leaks. We're good. And when we run our app, what do we want to do? For now, what I'm going to do is I'm going to load a dummy program into ROM. We're going to cycle through it. I don't know. I'll do like 100 cycles through it. We'll see what the output is, and then we'll go from there. So yeah. So app, we got our debugger, we got our VM. Right now we're just focused on the VM. So I guess we want to do like app virtual machine or VM tick and load program. So first we want to load the program, right? So we're going to give it our app VM. We need some sort of program with some sort of size. We're not going to worry about compiling and stuff yet, or assembling, I guess, and stuff yet. We'll worry about that later. Ooh, and one more thing that I was thinking of. I don't know. Yeah, we'll leave it this way for now. I was going to say, I should probably have like emu VM instruction. Yeah. Okay, so we're gonna have instructions, and these different instructions do different things. So for instance, we're gonna have add X. I might have to change that. So this is where we actually start looking at the specs here and stuff. So 0 is break, okay. And that's how we can actually get out. So break would be 0, and then this is how we'll kind of go from here. So that's 0. 1 is OR A. Okay, and you see what I'm doing here. If we do this, and I'm gonna actually do this, what's gonna happen is we'll be able to output these instructions directly into our ROM, so that when we compile, we can compile with type safety, or assemble. We can assemble with type safety, and then we can basically just blit all this stuff into our ROM, and that should just work. We'll have to do a little bit because this is technically 32 bits when all of these are 1 byte. So it's a little bit weird. And we have these illegal instructions. I'm not sure how we want to represent those. This is 255 things. So there's quite a bit of things in here. Do I want to represent all of these is what I'm wondering. Are these 1 byte or are these 2 bytes? No, there's 255. Yeah, we have FE to FF. Okay, that's just 1 byte, right? Or is that 2 bytes? That's 1 byte. 1 byte is 8 bits. Yeah, that sounds right. Okay. So for now, what we'll do is we'll say emu VM instruction no op. I don't know. What do we call the ones that are illegal? Illegal. Right? That's why I'm kind of like, I don't know. For now, I guess since I'm assigning these individually, we can just do this. So I'm going to go grab a few that I know how to use kind of. Push processor status onto stack. Okay, that's what that one does. So these are OR. Wait, whoops. Okay. So it looks like zeros are all ORs. Ones, we have branch. Okay, so it looks like these ones are all the branching type things. Then we have more ORs. Well, okay, they're all kind of scattered here. Clear carry. We have AND, bit test, rotate, pull. Okay, for now, I want just a few things. Exclusive OR. Let's see. Okay, yeah, so I want add with carry. So we're just gonna do a simple loop, and I just kind of want to see if we can get this working. We have add with carry. We have X index, okay. So this is 0x61. Okay, we're gonna do this. These are gonna be our add with carry instructions. So we have add with carry X indirect, okay? Yeah, and so since these are kind of represented this way, I'm gonna do this a little bit different. So we're gonna have add with carry X indirect, okay? And that's gonna be 0x 61. Okay, 61. So we got that, add with carry X indirect, add with carry 0 page. So that's the address scheme. I think that takes an argument, doesn't it? Where is that? Add with carry 0 address. Where'd that go? No, I think it took me to the wrong instruction there. Okay, anyways. Okay, so add with carry 0 page. Let's just add this here. And so by the way, these are different things. I did a very small primer, 0 page, 60 something. I did a very small primer. So basically you have different indirection schemes, which are basically how you go addressing memory. And so add with carry basically just says add whatever's in the X register to whatever's at the yeah. So it takes in certain number of arguments and stuff. It's all very confusing. It's not that confusing, but there's just a few different things that you kind of have to think about. And so these addressing schemes, I'm just going to kind of add like this. And I want to be explicit because that's a little bit helpful for me, at least. So add C, that's 65. Okay. There we go. And let me just see. We just lost a lot of brain power. Don't worry. I can provide jokes and all that stuff. Oh, and Voxroofs went. Okay, that's why we lost brain power. All good. Okay, so we've got add with carry 0 page. We're going to worry about those later. Pull accumulator, add with carry, immediate. Immediate equals 0x68 or something, 69? I don't know. 69, yep. Okay, then we have jump indirect. Okay, we'll grab some of that. So emu VM instruction, jump indirect. Jump indirect is 6C. 0x6C. And this is actually probably going to be easier if I just do this. And we kind of put this over here too. There we go. That's better. Let's go. Can I zoom out? Can. That's kind of small and it's kind of covered up by my face. This is the best I can do to make it not covered by my face. Let's do that. There you go. Nope. Almost. Okay. So you guys should be able to see that. Hopefully it's not too small. Okay. So we've got jump indirect there. Add with carry absolute is 6D. And that was add with carry absolute is, yeah, okay. C. Okay, we'll ignore rotate there for now. Add with carry indirect Y. Okay. That is 71. Add with carry 0 page X. Okay. Let's try and like keep some of these things. I don't know. We'll do this for now and then I can like reorganize later. Add with carry x0 page. That's 75. Okay. Add with carry y. This is absolute y. Emu VM instruction. Y absolute. Is that absolute? No, y indexed. 0x79. Okay. Add with carry absolute x. That is, my mouse is in the way, 7D. Okay. We have rotate there. Store Y, 0 page. Okay, that equals 0x84 is what that looks like. Yep, 84. Store A, page accumulator, 85. Okay. Store X, 0 page. I guess we should call this store instructions. Okay, emu VM instruction, store X, 0 page, which is 86. Okay, we'll do decrement stuff and all that later. Transfers, store Y. Absolute, which is 8C. Okay, and then we have store A absolute. Okay, equals 0x8d. I guess this is the very boring part of writing an emulator, is just getting the whole instruction set. Kind of type safety, all that stuff. VM instruction, this is store X absolute. 8E. And I'm kind of wondering, we want to make this a little bit easier to read. We're going to do ZP for 0 page. And apps for absolute. And IDX for index. Okay, and indirect is IND, which is indicative of the actual instructions too. Okay, so that's good. So indirect 0 page, immediate absolute, indirect 0 page, index absolute. Okay, cool. So kind of getting that out of the way too. That was store X absolute. Store A indirect. Yeah, does it tell you? Okay, there we go. Yeah, store A indirect Y. Oh boy, and this is kind of, okay, so then this is Y indexed too. So 0x91. Store Y 0 page X index. Store Y 0 page X index 94. Okay, so we basically just gonna have a bunch of these types of things. We have add, we have store, we have jump. And that should be basically all I need to kind of start writing the emulator. Okay, so now I guess the hard part is like, how do we take this and actually emulate it? We have to actually execute these instructions and stuff. So, oh, we should just void star. And that should be 0. No, you can't do that. Return. Oh, I guess we have to do it. DBG. Okay. So what I'm kind of wondering is, like, should I change the way that the ROM is instead of just having it be a bunch of bytes? Should we do something more sophisticated? I don't know if that really matters. Nah, I think we're going to leave it this way, and then we'll check and see if the byte is equal to one of these. Okay, and then we'll kind of dispatch based on that. Okay, so this is not happy. Why is it not happy? Okay, there we go. It's happy. So how do we actually execute a program? Or I guess we should tick. So how do we tick a program? First, ooh, okay, and this is kind of, So since the ROM contains an instruction followed by certain parameters, does the program counter, I assume it does. Program counter probably just tells you the byte offset of that actual thing. So I'm guessing what we would do then is, like, if we wanted to get the next instruction, next instruction equals program, I guess VM. Yeah, no, program VM program counter. So that would get us the next instruction, right? Then what we have to do is switch on our next instruction as like a... Can we do that? Can we say switch next instruction? And then just say like case emu VM instruction add C absolute. Does that work? G logger error. And this will give us a %. We want 0x8 or no, 0x% 8x. We probably just want 1x actually though. So this should print it in hexadecimal, and then we'll just print the instruction. So we'll do that. Sam, thank you for subscribing. Good to see you for 3 months on, and you're currently on a 1-month streak. So thank you for the tier 1 subscription, Sam. Working on a emulator because I've decided that all my projects that I have going on right now are not enough apparently. So this is just kind of something that I've been thinking of wanting to try, and we are in the middle of. Right now I'm just working on getting like a basic kind of interpret loop going. And then once we get the basic interpret loop going, should be good. And a Shark Tank. Have I worked with Arduino before? I have an Arduino in my closet that I have been meaning to work with, but I have not. So I need to eventually go ahead and do that. And Sam, yeah, emulators are cool to write. Yeah. We're doing it in C too. So we've got all C kind of stuff going on here, which is an interesting thing. I've never done that, you know, pure C. So it is interesting doing this. I'm wondering how I want to dispatch this stuff and everything too, though. I see. I'm just stuck with an issue and I don't have anyone to reach out to. I am sorry. I would help if I could, but Arduino is not my forte. So unfortunately, I won't be any help there. We have a Discord, though, too. And you might be able to find somebody on the Discord who is pretty good. Yeah. So everyone here is familiar with this stuff? I have no idea. See, Sam's worked with Arduino for many years now. Okay, see? So we've got some people who are familiar with stuff here. Okay, let's see. So we get the instruction. I'm guessing what I want to do then is just have like an interpret instruction or whatever, or execute instruction thing. Let's do this. Internal functions. Okay, we got that. So we'll give it our virtual machine as our VM. And then we're going to give it a, oh, see, I don't like this though, because it's kind of just, Oh, and this is wrong. I don't think that's right. Is it? Yeah, basically we have the program loaded into ROM. So at this point, we don't need that. Yeah, I don't really like this. Instead, what we're gonna have is like static void, right? We want to do like execute add instruction or something, and then that will do our add instruction, and then we give it virtual machine. Okay, and so fetch, okay, actually no, what we want to do is we want like a fetch, what is it? Fetch, execute, decode cycle? Fetch, decode, execute cycle. Fetch, decode, execute. Okay, yeah, so this is probably how we want to format this. So we'll have a static void fetch instruction. Okay. We have a decode instruction, and then we have an execute instruction. I'm just debating how necessary this is, because these instructions are really simple. But here's what we're going to do. We're going to say internal structures. Okay, we got that. So we're going to say we're going to have a struct instruction. Okay. And we're just going to call this a VM instruction. This will have a VM emu VM instruction type, or what did I call this? Emu VM instruction. So this is the type. Yeah, and this is a enum. Okay, cool. So we've got the instruction type there. Right, and then we have optional arguments, which is the next thing. So arg0, arg1. Yes, I think this is how I want to do it. And maybe I don't want to actually do like instruction type. I don't know. I'm trying to think of how the best way to do this is. So let me go back here real quickly. This is what I used to learn. And he has this thing, right? Okay, so basically, let's say we want to run this program. So we load A, this is a literal, so we load 1 into A. We store A at 200, which is a memory location. We load 5 into A, we store that at 201, and then we load 8 into A, we store that into 202. So, yes, okay. So basically what we want is we want an addressing scheme, right? So we're going to have like a type def enum address type. Okay. This will be indirect, indexed, or absolute. I think there might be more. Let's just reference this guy again real quick. Instructions, branching, addressing modes. Okay, I guess we should call this address mode. So we have absolute, 0 page X, 0 page Y, absolute X, absolute Y, and immediate and relative. Okay, so that's what we'll call this. We have these addressing modes. Okay, we'll go that, do that. Okay, so the thing I'm wondering too is because we have these XY things, I'm like, do we just call it 0 page or do we call it 0 page X? I guess we'll call it 0 page X and 0 page Y. But yeah, see, I don't know. Okay, whatever. So we have 0 page. We have 0 page X. Whoops. 0 page Y. We have absolute X, absolute Y. Absolute X, absolute Y. And immediate and relative. Okay. Or label. We'll worry about that later. Okay, so basically what we're gonna have is we're gonna have address mode. And this will tell us what kind of addressing mode we're using. Oh, and that's not even done yet, I don't think. Okay, implicit. Some instructions deal with memory locations, implicit and indirect. Okay, yeah, so we still have a few more things there too. We'll worry about that later. So basically, each instruction has an instruction type. And I'm wondering if I want to simplify that too. Yeah, I think we do. We'll say like type def enum base instruction. We'll call it that. Thank you, GI Troll, for subscribing for let's see, 2 months, currently on a 1-month shrink. Thank you for with Prime subscription. I can't see what the subscription types, and I'm like trying to find where it is all over here. But thank you, I appreciate that. Good to see you. So here we're gonna call this base instruction. And that will have like a store, or it's a load, or it's a jump, right? I think that's kind of how I want to do this. And this, I guess we'll have like the actual instruction type, the full whatever, but then we'll also have like base instruction, base type. And that will kind of give us like a easy way to tell exactly what this is. And the whole reason we're doing this is we're going to have like a fetch or decode. I'm not sure. Yeah, I think we're just going to call this fetch, and fetch is going to implicitly fetch and decode next instruction, right? And then we're going to have an execute instruction, which kind of does that stuff. Good to see you. Thanks. So yeah, we're basically going to have that. And then this will actually go ahead and execute that instruction. Instead of execute add instruction, we'll have like that. So we have like our fetch, and then we have fetch and decode wrapped up into one. And then we have execute, which takes that decoded instruction and goes ahead and like actually modifies things as needed. Okay, so got to think about this just a little bit more too. One more thing that we want to do is like a size t. Okay, how much do we increment our program counter? How much do we increment the program counter after we execute this instruction? Or while we execute this instruction, I guess. That will kind of embed inside of that decode. So like if it's a store with address mode 0 page X, then we're pulling X off as a parameter, right? Which would basically imply that, yeah, we've got something like this. Well, let's see. Yeah, okay, so basically here, right? We have load X, which takes in a argument. I think there's ways you can do multiple arguments too. I don't know if this tutorial actually supports that. Yeah, I don't think this actually supports that. But if we actually take a look at the instruction set here, let's take a look at this one. I'm looking for some easy to read. Okay, here we go. So like compare X register. So it gives us the mode, immediate mode. It gives us, oh, so this is for immediate mode. What it does is it takes that. The length is 2, time is 2. So that's the cycle, and I guess that's the instruction count length, right? Oh, and then I see here. So absolute is a length of 3 because that has 3 bytes. Yeah. Oh, okay. And I guess that's kind of what we should call this, right? So this isn't the program counter. This is the instruction length, which we can actually encode in just a uint8. And that's how much we need to increment our program counter afterwards. Okay. But do they all just take, okay, yeah, here we go. This is what I was looking for. So basically we can have things like decrement 44x, which has 2 arguments. And I think you can only do up to 2 arguments is like the most. I just want to be clear. Here's like some example stuff here too. Let's just kind of glance through this. Yeah, so basically we have like store A 0x. Just kind of looking through here. What are these +4s too? I didn't realize you could actually do like inline addition. I don't know if that's correct or not, but interesting. Okay, so it looks like you can only have like up to 2 arguments at most, which is kind of what I was looking for. Yeah. So let's just do that. We'll have a we'll do that. Okay. So kind of thinking through this, we're basically gonna have this fetch instruction, which goes ahead and translates from something like this, which is just a byte, and it actually tells you exactly what kind of thing it is. And that's just going to decode it into a little bit nicer of a type that we can use. So let's go ahead and do this. Go down here, put that there, put that there. Get rid of that. Okay, so we have our uint8 next instruction equals VM. Yeah, VM ROM, right? We go from the program counter to ROM. I guess what we want to do too is like say this initially equals VM break. So VM instruction, do we have break in there? We do, okay. So we'll initially set this to break. Okay, there we go. emu VM instruction break. And then what I'll say is if VM program counter is less than or equal to, or actually we just want to do less than, ROM size, then we'll do this and do that. So if we run to the end of the program, I'll just automatically interpret that as a break command. Otherwise, we grab the next instruction, and then we want to switch on that next instruction, and we'll kind of do the decoding here. SE Woods, is this the microphone the same one that I use while I record my singing? I don't do any singing, but it is the same one I use to record videos and stuff, so that is true. We'll go ahead, VM instruction res. So, case. Let's go ahead and handle the first one, which we did up here, which is break. And if we do a break, what do we want to do? I guess we should basically just like halt program or something, right? Just stop it. So let's add one more thing here, bool. Or actually, I guess we can just add that to our base instructions, right? Break. So, which I'm going to set to 0. Okay, so if we hit this, we're going to say res.base type equals break. I forget, I'm in C, so I have to prefix these to make this a little bit easier. We'll do that. That's not what I meant to do. Okay, we'll do that. Press escape. So we got all this. We've got all this. Okay. So base instruction break. Okay, there you go. And then I actually will break there and we'll return that res. So simplest instruction I can think of here. And a Shark Tank. So what is this emulator for? It's going to emulate 6502 NES style 6502 right now. So I guess eventually I'd like to run an NES game on it. But what I'm doing is I want to code in 6502. And I figured a fun project would be, let's create an emulator with an IDE and everything and a debugger. And then I can also use that to code some games in 6502. So yeah, NES style emulation is what I'm going for. And then I eventually want to be able to like distribute games that run on this emulator, except they're like 6502 style and NES style and everything. So that's what it's for, I guess. SU, do you remember tuning into one of Cherno streams and there he sat singing? Yeah, don't worry. I won't be singing anytime soon. That's for sure. Got to keep up. No, I'm good. No, thank you. Okay, so I guess what we should do is we should have like figure out the addressing mode first, right? So case emu VM instruction. Yeah, so let's modify this slightly. So I want to do address mode, then the instruction type, and then the register that's acting on. So this is indirect address mode. This is 0 page address mode. This is immediate. This is absolute. This is indirect. 0 page. Index. Absolute. Okay, so I just swapped this up a little bit. And the reason for this will become clear in a minute. So let's go ahead, swap this around. This around. That. Okay, so we got all that. And then same thing here. 0 page. Okay, 0 page. I wonder what these kinds of things are addressing. So does this even need an address mode? I guess is an interesting thing. I think that would be immediate then. I don't know. I'll have to look at that again. 0 page, absolute, absolute, and these are both index. Okay. So let's go ahead and remove that, that. Okay, so the way I'm going to have this work is first we're going to figure out the addressing mode. So case VM instruction. Yeah, okay, here we go. So yeah, we can do this. We'll say absolute whatever. And then res.base type, or I guess we could say like address mode equals address mode. And this is absolute. And then we need to figure out if it's absolute X or absolute Y. Okay, so this is why I kind of didn't want to do that. Let's change this. So address mode, we're just going to have 0 page. And we're going to have absolute and immediate and relative, okay? And then we're going to have a type def register mode. This is going to be register X, register Y, register A. Accumulator X and Y. Do it this way. Okay, so then the instruction is also going to have that, which tells us which register we're dealing with. So when we go down to here, we can say address mode equals absolute. Okay, break. And we can go down into here, add CX, absolute store A. Whoops, already did that. We did store X, store Y. Okay, so that's all of our absolutes, right? So this way we can do sort of this type of thing. Then we'll have a case emu VM instruction index, okay? And res.address mode equals kind of grab that and put it here. I don't know if indexed is one of these. Immediate, relative. I think relative is indexed. Let me just check this guy real quick. Oh no, they have indexed, indirect, and then they have indirect, immediate. Okay, so it looks like you can go indexed, which adds to indirect. Wait a second, let me just check this again. Okay, so basically index just tells you if it's like a longer instruction, I think is all that does. But we'll kind of keep that. And I'll change this stuff as needed later. Okay. So we got add CY, store A. Okay, yeah, so then we have indexed indirect. 0 page. Oh, okay, so index is just kind of like a type. Okay, that's something we want to change here. So I guess that could just be represented by a bool. Bool is indexed. So we will just have it like that. And these will all toggle on indexed or not. Okay, so index isn't really an address mode. So inside of my virtual machine, we want to change the way these are organized a little bit. So this is actually still technically add carry. I guess this is immediate technically. We'll look at that later. Is this immediate mode? Yeah. Okay. So 0 page, absolute, and immediate and relative are the ones that we actually have to worry about. So let's just change this up a little bit. Case emu VM instruction immediate. And let's also go up here and just remove that. Okay, so we've got immediate. Okay, we've only got one immediate instruction right now. VM instruction. We have 0 page. Okay. I'm still not sure what the best way to do all this stuff is going to be, which is why I'm only doing a very small subset first to start with, and then we can start expanding once I get the basics figured out. Okay. So we have absolute, immediate, 0 page, and then relative. Let's just see what they say for relative here again. Oh, these are for branching instructions. Yeah, so that's what it looks like. Yeah, so that means skip the next two. Okay, that's kind of interesting. Anyways, Man, 4-hour stream today. Yeah, I know. I'm getting close to being done with this because I am getting tired, as you can tell by not being able to speak anymore. Okay, so basically, I think we've got the basics of this kind of figured out. We're gonna have this fetch instruction which figures out the addressing mode. We're gonna figure out if it is indexed, which means that it takes the next 2 bytes off for an address. And then we need to figure out which register it affects. So those are kind of like those things. And then once we get that, we store it in this instruction. And then that goes through and it executes the instruction by kind of using all these different kind of sub instructions, I guess, to figure out how it should go. For now, though, I think we're probably going to leave it here because until I get this a little bit better. Or take some more time to understand assembly. 6502, it's probably not going to be the best. A Shark had a question. Oh, so it may seem like a stupid question, but what exactly is 6502? Oh, 6502 is assembly. So it's the assembly that was used on the NES, Commodore 64, and a lot of other machines at that time. It's like nowadays we have x86 64, which is x86 is the flavor assembly, and that's Intel. And then AMD has, I think, I don't know what you call Intel or AMD assembly. They use, I think they use x86 too. I think that's common between them. Yeah, x86. Okay, so you've got like x86 assembly language. You have different assembly languages for different instruction sets and everything. Yeah, 6502 is a microprocessor. That's the easiest way to explain it. Yeah, basically. Well, it's not technically a microprocessor because the NES had a different microprocessor than the C64. It's just the instruction set. And then what you can do is you can use that instruction set, which we find here, to actually code programs that run on all these different machines. If I zoom that in a little bit more again. And then you can basically interpret that and write an emulator and everything. So, yeah. Definitely nothing you've never worked with. So, yeah, no problem. And Valkyries, wait a second. I'm pretty sure 6502 is an instruction set. Yeah, so it's the instructions for, yeah, because you could have 8-bit 6502 processors and definitely and other things and stuff. So, yeah. But let's go. I just want to add in a couple things here, which is we're going to say when we tick, we fetch our instruction, or I guess we just call it, fetch instruction, give it the VM, then we execute the instruction. We give it that and the instruction, which is that. Right? That returns VM instruction? Yeah. Oh, we passed that by reference. Okay, so that's basically how it's going to go. I mean, if we step into this, we should at least be able to like kind of step through. We're not loading any programs or anything, so it's not going to do anything interesting, but it should at least compile, which is where I would like to get this to, just so that we have that ready. EM already has a body. Oh, can we not even, oh, we can't even overload like this in C, can you? I forgot about that. So I can't even do two functions with the same name. That was what you were talking about earlier, Voxorifs. Okay, so with this, we'll say init size. I don't know what you call this. Okay, so we have init and then init overload. No? Init with type? I guess we'll just call this sized init. Okay. So we've got that. And this we'll just call sized init. Okay. Yeah, that works for me. And we pass it the VM type. Okay, here we go. So let's do that. Does it compile? Not yet. Program size undefined. So we just want to comment that out for now. Okay, yeah. So we can jump into this. This goes, creates a debugger. All that stuff. Oh, I need to initialize that too, don't I? That would be nice. So we actually need to go emu debugger init. Yes. Okay, so then we can say star debugger equals that. Star VM equals emu VM init. VM type. And for now, we're just going to say type NES, which is what we're going to initialize it to. Okay, so now if we were to go into this, let's just make sure this all kind of works. So we allocate that, we initialize it, which just does that. So that's 0. Our debugger is now 0. Here we go and we initialize all this stuff. So goes ahead and does that. And now if we take a look at it, okay, cool. So we got NES, we have our program is 0, all these are zeros. We have 2048 for our RAM size and our ROM size is 49120. Cool, so that's all good. We return that, we run it, which right now does nothing. We free it, which right now just goes and frees all that stuff. And then we should have no memory leaks. So if I just go ahead and wrap that up, we have no memory leaks. Okay, cool. So, and we should probably just add like an extra thing here too. Logger info VM NES VM, right? Eventually that'll be Commodore 64, but for now, nothing. So we do that. And then when we free it and everything, we should probably just say like, I don't know if we should say anything. I don't think it really matters. Okay. For now, that's all we need. Yeah. So if we were to run this just to make sure we're actually getting stuff. No, we get no glogger info. Did I not say? Oh, that has to be above that, clearly. So instead of doing this, we'll say that, and then we'll say return res. Okay, there we go. So now we should get that. There we go. We get it printed out. So we kind of got this all started up. Let's go ahead and push this. Let's add all this. Let me just actually add a git ignore too. Let's call that dot git ignore. Yes. We'll just edit this. Can I not just, okay, whatever. We'll open it with code. I want to ignore anything VS. Do that. We want to ignore our bins. And, oh, star.sln, so ignore all that. VCX proj. So ignore all those. Okay, and I think that should be it. So if we do git add, git ignore, let's just check the status again. So yeah, that didn't work. Okay. Missing a C in there. Okay, I have to add filters to, can I just do dot star star? Does that work? There we go. Okay, so that got everything. So then we can just say git add dot, git status, make sure I didn't add anything that I don't want to add. Yep, that looks good. Then we'll commit add initial project structure. Okay. I guess this is on the main branch too. We don't have master branch for whatever reason. Okay, cool. So that's it. If you guys want that branch, that code, let's just go. I forget what I called this. Let's check it out here. Okay, so here's that branch for anyone who's interested. Doesn't do anything very interesting at all right now, but it will hopefully do some interesting stuff eventually. Thank you guys for watching. I'm just going to check real quick. I think it's time for a second muffin now. I agree. I like my init functions take a pointer as well. Reason for that being I can make the struct itself act as the parameter since you can just, yeah, I might change that in the future. We'll have to think about that. But anyways, thank you guys for watching. I hope you enjoyed. And next week, I'll hopefully take this a lot further. I'll look a little bit more at the 6502 code just so I have a better internal model that we can represent with this stuff. Yeah. Thanks for watching, guys. I'll see you.